In this video for Computer Science 9618 A-Level, we're going to be going over how to use K-maps. So let's take a look at those learning targets. They want us to show an understanding of Karnaugh maps, which are K-maps, understand the benefits of using Karnaugh maps, and how to solve logic problems using those K-maps. So this is what a K-map looks like. Now this is for three variables. We have three variables, A, B, and C. A has two possible inputs, 0 and 1. B, C, there are four possible inputs, where both B and C are 0, where B is 0 and C is 1, where B and C are both 1, or where B is 1 and C is 0. That's for three variables. We'll be going over how to use this. We'll also be going over how to use a four variable one. A and B can be on the top, C and D can be on the side. It does not matter where it goes. It does matter what order you follow. These are in a specific order, so let's talk about why. So Karnaugh maps, you need to set them up. Sometimes you'll get a K-map that already has this filled in. You really don't want it filled in for you. You want to be able to set it up because it's so easy and it's free points. Now, when you're setting up your map, only one variable can change when you traverse a row or column. And this is why the top goes 0, 0, 0, 1, not 1, 0, then 1, 1. Notice it goes from 0, 1 to 1, 1, then 1, 0. Here, A, we have 0. It changes to a 1. Only one variable changes. But on the top row, for B and C, when I go from 0, 0 to 0, 1, only the second variable, the C, changes. When I go from 0, 1 to 1, 1, only the first variable, the B, changes to a 1. I can't have this as 1, 0. That means the B would change to a 1. The C would change from a 1 to a 0. That's two variables changing, not one. And then for the last row, when I go from, or last column, when I go from 1, 1 to 1, 0, only the second variable changes from a 1 to a 0. So that is an error. It should say from the 1 to a 0 because this C is changing from a 1 to a 0. Now, the first thing you must do once you have it set up is to fill out the K-map table. Once that is done, you can start finding the simplified Boolean expression. And this is what K-maps do for us. They allow us to find the simplified Boolean expression. Now in the map, you look for the variables that do not change. We're looking for the values for variables that will stay the same in our grouping. When you find the grouping of ones for variables that do not change, you include them in your simplified Boolean expression. Now, let's talk about the rules of K-maps. Let's find those grouping of ones and let's put it all together so you can be an expert at this topic. So the rules, the grouping of ones must be 2 to the power of x, and you must circle the largest grouping possible. Now you cannot circle 3 ones because 3 is not a result of 2 to the power of x. So if you see 3 ones, don't circle them because you cannot get 3 by doing 2 to the power of x. Now, here are some examples you can circle the amount of. You can circle a single one because 2 to the power of 0 is 1. Now this is extremely rare, but it does happen. You can do 2 ones because 2 to the power of 1 is 2. You can do 4 ones because 2 to the power of 2 is 4, and so on. So those are things that you need to do. Here are some things you can not do as well. Oh, some other things you can do. Your circles can overlap from one side to the other, either vertically or horizontally. Now we're going to look at these today so you can see this. And a 1 can show up in more than one grouping. You need to be aware of that. We have an example on that as well. Now, not getting ahead of myself, now there's something you cannot do. You cannot circle diagonally. This is not allowed. It's going to result in an incorrect answer if you try it. So now that we've gone over the rules, we've gone over the setup, let's talk about how do I identify the largest grouping of ones. So here we have a K-map that has already been filled out. I have already filled it in. Let's find our largest grouping of ones. Now remember, the largest grouping of ones must be an amount that is a result of 2 to the power of x. Boom. Here's my largest grouping. I can circle 4 ones here. They're next to each other. My circle is not going diagonally. 2 to the power of 2 is 4, so that works out. Now, is that all though? Well, no, because I have another one, and I can circle this one right here. 2 to the power of 0 is 1. Is that my largest grouping of ones though? Well, you can see this one will be included into 2 groupings because remember, they are allowed to overlap. 2 to the power of 1 is 2, and because they can overlap, this is my largest grouping right here. If I circle this one by itself and do not include this one, I'm going to get the wrong simplified expression. Now, let's talk about how we solve the simplified expression. So here's our K-map. We just circled the largest grouping of ones, but how do we use that and implement it so we can get the simplified Boolean expression? Now remember, we're looking for the variables that do not change in value in our grouping of ones. So let's look at the first group of ones, which are these 4 ones that we circled. Those were the first one we identified. You can identify them in any order. We could start with these 2, but we're going to start with the 4 largest ones. The first thing I want to ask myself is, does the value of A change? Well, what is the value of A in this box? Well, I see A is 0 in this box. In this box, A is also 0. So far, so good. Now I got to check this one because it's part of my grouping. What is the value of A? 1. That's it. A's got to go. The value of A has changed from 0 to 1. If it was the same in all 4 of these boxes, I would keep it. Because it has changed, it's out of there. Now I have to ask myself, what about B? What about C? We do not check B and C together. We check them independently. So in this group, I look at B, or in this box, I look at B. B is 0. I check the next one, B is 1. B is out of there. What about C? The value of C in this box is 1. What about this box down here? The value of C is still 1. Go over checking this box. The value of C is 1, and in this last box down here, C is also 1. Because C does not change, I'm going to keep it. Now, we move on to the second grouping. I look at the value of A. What is the value of A in this box? It's 1. What is the value of A in this box? It is 1 again. We are going to keep A. What about B? In this box, the value of B is 1. In this box, the value of B is 1. I'm going to keep it. What about C? In this box, the value of C is 1. The value of C in this box changes, so C has got to go. So we have C from the first 4 grouping. We have AB in the second grouping. So we put a plus sign between them. C or AB is our final answer. Remember, the plus is read as an or when you're doing logic expressions or Boolean expressions. A, B, or C would also be acceptable as an answer. And that is the simplified Boolean expression for this problem. So let's go ahead and do one from start to finish. So how did I get those ones in the previous problem? Well, you have to have information, and using a truth table, you'll have all the info you need. You don't just magically pop in the zeros and the ones. So we're going to need a truth table. Here's one. So let's find where the outputs are 1. That's what we need to look for. So here we have an output of 1. Here I have an output of 1. Right here I have an output of 1, and then my last output of 1. So I know I need 4 ones in my K map. So how many variables do we have? Well, I see we have A, B, and C. Those are 3 variables. So I need a 3 variable K map. We need one of those. Here's another one. So perfect. Let's go ahead and fill that in. When A is 0, B is 0, and C is 0, I'm looking for 0, 0, 0. It is a result of a 1. I put in a 1. What about 0, 0, 1? 0, 0, 1, that also results in a 1. When A is 0, B is 1, C is 1, that's going to be 0, 1, 1. And see, that also results in a 1. Then I have A is 1, B is 1, C is 0, so I'm looking for 1, 1, 0. Here's 1, 1, 0. That does not result in a 1, so I'm going to put in a 0. What about when A is 1, B, C is 0, 0? So we're looking for 1, 0, 0. That doesn't work. That's a 0. What about 1, 0, 1? Here's 1, 0, 1. That works. What about when all 3 are 1? That's a 0. And what about my last one? 1, 1, 0. I see that is also a 0. So now that we've done that, we need to find our grouping of ones. Here's the first one. This is my largest grouping of ones. Remember, I can't include this one because I can't go diagonal. I can't circle all 3 because 2 to the power of x does not get me 3. What about the next grouping? The next grouping is going to include 2 ones, and that is right here. This 1 is overlapping, and that's fine. So the largest grouping I can have are 2 ones. What about the third grouping, because there is one more grouping, and that is going to be right down the middle here. This one overlaps, and then it can overlap more than one time. So from grouping 1, which is green, checking the values do not change. What is the value of A? 0. What is the value of A in this one? 0. How do I represent 0? By saying not A. What is the value of B in this first box? 0. What is the value of B in this box? 0. How do I represent B as 0? By not B. Looking at group 2, which is the red. What is the value of A in both of these boxes for the red grouping? Not A, because it is 0. So 0 becomes not A. What is the value of B? Well, B is 0 in this one. B changes to 1. Get rid of B. What about C? C is 1 in both of these. How do I represent C as 1? By a regular C. And then my third grouping, here, A is 0. In this one, it's 1. Got to get rid of A. What about B and C? Do both of those stay the same? Here, we have B as 0. Here we have C as 1. But remember, how do I represent B as 0? By a not B, C. So we put in a plus sign or a or sign in between these, and our final simplified Boolean expression for this truth table is not A and not B, or not A and C, or not B and C. And that is the simplified Boolean expression. Now, something you may see is something called the sum of products. Now, the non-simplified version from the truth table is called the sum of products, and you may be asked to do the sum of products. So let's write out the sum of products real quick and we'll figure out why they're called the sum of products. In the first solution, right here across the top, we have the solution not A, not B, and not C. That is one solution. The second solution here that works is not A, not B, and C. The third solution, we have not A and B and C. And in our final solution, we have A, not B, and C. So each solution uses an AND gate, which is equivalent to multiplication in algebra, hence the products. Each of these are products. We put an OR gate between them, which is equivalent to addition in algebra, hence the sum, and we get the sum of products. Not A, not B, not C, or not A, not B, and C, or not A, B, and C, or not A, B, and C. Actually, that should be A, not B, or C. That was a copy and paste error, because trying to get these lines over the top can be, but this is what the fourth one should be, A, not B, and C. Put it all together, we get our sum of our products. Now, this is not the simplified Boolean expression because we just used our K-map to find out the simplified Boolean expression. If you're not asked for that and you're just asked for the sum of products, you write out exactly what you see. Here, A is 0, B is 0, C is 0. It's a 1, which means it works. How do I represent A, B, and C as 0? By using a NOT gate over each of those. That is the product. We put an OR sign in between them. All right, so alternate solving. Earlier in the video, I said this could be A, B, and this could be C. So what we want to do is we want to run the same problem, see if we get the same answer. So we're going to set it up a little differently. Do we get the same result? That's what we need to figure out. So going through all of this, filling it out, this is what my truth table comes out to. Now I have a 1 all alone over here. That could be a little tricky. So here's my first grouping. I have not A. Oh, no, excuse me. Oh, yeah, that's right. A is on top now. So what is the value of A in this box? 0. What's the value of A in this box? 0. So I have not A. B changes. C stays the same. Here's my second grouping. What is the value of A in both of these? 0. What's the value of B? 0. So we have not A, not B. What's the value of C? It changes. Now, what about that third grouping? Well, our third grouping is on here, and it's not the single one. We said the groupings can overlap from one side of the map to the other. This is how you show that. We circle this one, we leave it open. We circle this one, we leave it open to show that they are being grouped together. So group 1, the green circle, we have not A, not B. And then group 2, we have not A or C. And then group 3, we have not B or C. that is what we have, and we get the same answer, and that's just what we got earlier. Not A and not B, or not A and C, or not B and C. So when we look at this yellow one, here we have A and B are both 0. That is the not A and not B. The green is not A and C, because B changes, so we get rid of B, because B is 0 here, but then it changes to a 1. And then when we check out the third one, we see B in both of these, which is the second variable, is 0, so that's not B. And then C is a 1 in this box. C is also a 1 in this box. And that is our simplified Boolean expression. So when I said earlier, you can have this set up differently, you can. It'll work. Here we had B, C. Here we had A. And all we do is follow the truth table, and it works out every single time. So even if your K-map looks slightly different, you should still get the same groupings and the same answer. And that's what makes K-maps so nice. So let's go ahead and allow you to try one. You have a blank K-map here. Use your last example, but go ahead and pause the video and give this one a go. Okay, so you're going to create a Karnaugh map, circle your grouping of ones, write your simplified Boolean algebra expression. If you followed those steps, then you are good to go. You completed the entire K-map. So let's go over. This is how I set mine up, A, B, C. That's how I set mine up. And then, using my truth table, I was able to fill this in. When A is 0, B, C is 0. That results in a 1. Then I have 0, 0, 1. That results in a 1. 0, 1, 1. Here's my 0, 1, 1. That results in a 1. And then 0, 1, 0. 0, 1, 0. That results in a 1. When I have 1, 0, 0, that's a 0. When I have 1, 0, 1, that results in a 0. When all three are 1s, that's a 1. And when I have 1, 1, 0, that is a 1. I count my 1s. 1, 2, 3, 4, 5, 6. And I do have 6 1s in my K-map, so I did not forget one. So our final answer, when we circle this grouping of 1s, we're looking for the value that does not change. What is the value of A in this box? It is 0. What's the value of A in this box? It is 0. What's the value of A in this box? 1. It's got to go. We check B. The value of B is 1 here. The value of B is 1 here. What about in this box? Checking, the value of B is 1. Here the value of B is 1. I'll let it stick around. When I check C, C is 1 in this box. But when I check this box, C is 0. It's got to go. Then I look at my next grouping. I see A stays the same, so that's going to be A staying 0, so that's going to be not A. So then B, unfortunately, changes. C also changes. It's got to go. And our simplified expression is simply not A or B. That is a simplified Boolean algebra expression. So try the 4-variable example. Let's go over this one. This one is just as easy as a 3-variable one. You just got to check one extra letter. So the first things first, we set up our K-map. Now notice, we're still following that same rule. 0, 0. When I traverse the column, only one variable changes, which is B. When I traverse to the third column, only A changes. This 0 becomes a 1. The B value of 1 stays a 1, and when I go to the fourth column, only B changes to 1, 0, and I follow that same method down here. Now, what you need to know if you're writing your numbers like this, when you have 0, 0, the first one is C, the top one is D. So we have 0, 0, 0, 1, 1, 1, 1, 0. So what I do is I simply identify where my 1s are. I have 5 1s, so I should have 5 on my K-map. Let's look at this first one. I'm looking where A is 0, B is 1. Here it is. And then I'm looking where C is 1 and D is 0. This is where they meet up, so I put a 1 there. I look for the next one. A is 0, B is 1, so I know it's going to be in this column. And then I'm looking where C and D are both 1. It's going to be right here. 0, 1, C and D are 1, 1. They intersect right here. I put a 1. Then I look for the next one. A is 1, B is 1, C is 0, D is 1. So I'm looking for 1, 1, and then C is 0, and D is 1. It's going to be right here. And then I'm looking for my fourth one, which is A, B is 1, and then C is 1, D is 0. So that's 1, 1, 1, 0. That's going to be this box right here. And then I'm looking for my last one where all 4s are 1s, and that intersection is right here. Now, in the previous problems, we showed where the zeros go. You're not always going to have time to do that, especially if you have a 4-variable one. So what you want to do is, once you identify all the 1s, all you need to do is go in and fill in all the zeros, and that will actually expedite the process. There's only one thing left to do. Circle our largest grouping of 1s. So here's 1 right here. This is a grouping right here. I can't circle more than that because that's not an answer of 2 to the power of x. So I'm looking for the variables that do not change in this grouping. So what is the value of a? 1. What is the value of a? 1. What is the value of b? It's 1. What's the value of b in this box? It is also 1. We got to check c. c is 0, but then c changes to a 1. It's out of there. D. D is 1. D is also 1. So we'll keep that. Then here's my last largest grouping of 1s, and I'm looking at A, and I see when I go from one column to the next, A changes. What about B? Well, B is 1 here. B is 1 here. So here, B stays the same. In all 4 of these boxes, B has the value of 1. Then I check C. This value of C is 1. The value of D is also 1. But down here, the value of C stays the same. The value of D changes from a 1 to a 0. So our final expression is going to be ABD or BC. So one more time. Right here, we see the value of A stays the same. The value of B stays the same. C changes from 0 to 1, but D stays the same. D stays 1 in both of these, so I'll keep ABD. And this grouping of 1s here, I see that A does not stay the same. B does stay the same. B has a value of 1 in each of these boxes. And then we look at C. C has a 1 in each of these boxes, while D does not. So use your last example and give this one a try, and then we'll go over it. Okay, so what we're going to do is we're going to find out where the 1 is, and there's only one 1 on here, and that's when everything is a 1. So here is where A and B is 1 and 1. C and D is 1 and 1. That's where my 1 goes. That's the only one that works. Zeros in the rest. And then I circle my largest grouping of 1s. And you may be saying, well, hold on here. We only have 1. 2 to the power of 0 is 1. And our simplified expression is ABCD. Because in this box, A value does not change. It stays a 1. B is a 1. C is a 1. D is a 1. And matches up with our truth table. And just like that, K-maps can be done successfully. I hope you guys found this video helpful. If you did, please give it a thumbs up and subscribe to help the channel grow. We'll see you guys in our next video.